that you've just written down is a list of all the things in this topic that eventually, not just after today, eventually you will hopefully know how to do them all. Okay. So if you talk about what's your revision list, well, there it is. That's the page of things that you need to be able to do. There will be a couple of other things as well, but generally this time, this is it. So, go through it very quickly. I want you to know how to use inputs with a function to find the output. We went through that yesterday. So, you've already got that sheet. So remember we had x and we put it into the function of x. So for instance, you're putting x into maybe 1 plus 3x, and what was the output? So, depends what x is, yeah? So if I put 2 in, what comes out? 7. Okay?
Oh, I think line looking wise.
No. So just can you put a function, an input into a function, find output? So we did those tables. Alright, so that sheet in the booklet. Yeah, let me just reopen. Okay, so this was that. So about putting the function in, working out the outputs. But from that, okay, fill out the table by hand or using your calculator. Remember we used your calculator yesterday. Then it was about, I want you to be able to plot those ordered pairs. Now, do you know what I mean by ordered pairs?
I've heard of them.
You've heard of them. Do you know what they mean? What I mean by that?
I did it already somewhere, I can't remember.
No? Anyone else? What do you think it means? If I say plot the ordered pairs,
Isn't it like 5 and 5? Like 1 and 5.
why would you say minus 5 and 5? Are you saying minus 5 goes with 5 all the time, or are you just picking 2 numbers? Well, on the board, for instance, I have an ordered pair there, 2 and 7. Okay? So the input goes with the output. They're a pair of numbers. They're called an ordered pair because they tend to go in order. You would also know ordered pairs, once they are plotted, they become what? They become coordinates. Okay? So once you've plotted them, they become coordinates. And you just plot them on a set of axes to show the behaviour of a function. Now the function that we're going to, the ones that we're going to be looking at are all going to be what shape, did we say?
Straight lines.
Straight lines. That's the one we're looking at. We are looking at linear functions. Right? But remember yesterday we talked about other shapes, but we are now looking at linear functions, so the straight lines. Right? What do I want you to be able to do then? Well, when we have this graph, what we're going to look at today, find the gradient. That's probably the first important thing we're going to have to do. Write the equation of the line. So if it gives you a line, can you write the equation of it just from the line? And we're going to use the gradient and a known point. So if we've got the line in front of us, it's easy. If we're given the information about gradient and intercept, can we do it without the line? Can we write the equation of the line just from given 2 collinear points? Do you know what I mean by collinear? Any ideas? Collinear means? Collinear means on a line. That's what I wanted to write. Just on a straight line. So you're told if it's a linear function, collinear just means on a line, on a straight line. Okay, collinear. So they share the same line, basically. So if you're told 2 points are collinear, you know it's on a straight line. And then we move on to knowing the relationship between parallel and perpendicular lines, and that's got to do with gradient. Okay. So we'll look into that. Do you know what parallel means? What does parallel mean? Yeah, lines that never touch. We've got a symbol for 2 arrows like that. Do you know what perpendicular means?
They are not crossing.
But not just crossing, I don't know what I've drawn there, but actually crossing at a right angle. So there's 2, makes the parallels easy, perpendicular is easy, but a little more of a step. So these are things I would like you to know how to do. I'm in the middle of explaining. Can you wait till we've done that? So to start off with, just do it quickly. We're just going to look at gradients. Alright, so we've got this sheet. You already had it for a lesson. You all know pretty much how to do it? No? Some do, some don't. Did you understand what I wrote here? So on the top I've said gradient or slope, different name, same thing, is rise over run. When I say rise over run, I mean division. So you take the rise of the function and you divide it by the run. So I say rise over run, but it's a division. And how do we work out that? Well, on our diagrams, I showed on here, this one for instance, that what we need basically are two known points on the line, and the easiest way on these ones is you take the two at the end. Okay? I could use the one in the middle as well because I know that point, but it's very important that you only take points that you know for certain. Some people make a mistake because they look at it and go, well, that's nearly that point, but it's not. If it's slightly off, it's not on it. Okay? So remember back to the table of values. If you haven't got a value that's in the table, you can't use it. So rise over run means, well, run, what I'll say to you now, run always goes left to right. Always goes left to right. Right? If you ever find yourself going right to left, there's a flaw in your method. But rise, however, could go up or it could go down. Okay? And if you have a rise that is an uprise, you will end up having a positive value. Okay? If you have a down rise or a drop, you will have a negative value of rise. So that, if it goes up, having gone like that, you get positive. If it goes down, you get negative. So what do I mean by that? Well, if I look at this one, I find the first point that I know, which is here. I run in this direction. Okay, so I go left to right. And what I do is when I get to the point at which I can go straight up to the other point, okay, I stop. And I have to figure out, well, how far did I have to run? So that's why I've got -1 to 1, which is a run of 2. And then my rise was -5 up to 5. So 10. So then my slope, my gradient, it's not written very well, but it's 10 divided by 2, which does equal 5. Okay? Make sense?
Yep.
Okay. Let's move on to this one. Now what do you notice mainly about the direction of the lines? The difference. So this one goes up if we're going left to right. This one goes down, and that's why this one ends up as a negative. Alright. Again, I start with the left-hand point, and my run is left to right. When I get to the point where I can reach this point, I then go down. So it's not up, it's down this time. So my run is from -5 to 5, therefore 10. But my rise is actually a downward rise, therefore it's from 2 down to -2, so I actually do -4. Now rise over run is then -4 over 10, which makes -2 over 5. Now, my tip for you, although you might not like it to start with, is always leave it as fractions. Simplify the fractions, but leave it as a fraction. Right? Hopefully, to start with, most of them will be whole number gradients, but if you end up with a fraction, leave it as a fraction. And you'll see why that becomes a lot easier. Okay? And all the rest, you just follow the same thing. Okay? how far have people got with the rest? Have you kind of done them or before? Some of you have done them, some of you not. Okay. Right, what I'll do then, just so that people can move on, let's have a look at, I think this one. You got this one?
Yeah.
Okay. Did you have a go at this one?
Yes, we did this one.
Is that easy enough as well?
Yeah.
Okay.
I don't even know what page.
Next one was this one. Find the set from the pair of points. I got that one. We did it, but
Which one would, okay.
I got
Oh, this.
the y-intercept one.
We're just gonna do the last 2 pages. 3
That one.
pages.
I have a question.
Yeah.
So for the rise of a run, if you get like an answer that can't be like simplified, like,
Leave it.
you just leave it like that?
Yeah, I would say the reason is I've got a question that I've just been given to my IB ones, so it shows you how this topic follows through. Okay, let me run through this. Let's see whether you can do it. Let's see how close you are to this point. Are you okay with doing that? If you don't want to do what I'm doing now, if you want to get on with the gradient stuff, feel free to carry on. Otherwise, work with me and we'll talk this through. Right, so I've got, it says in this question, a straight line, L, that's what it's called, goes through 2 points. Point A has 1, 4, and B is at 5, 8. So I know these 2 points, it doesn't say in this question, but these 2 points are collinear. Okay. Who thinks, out of you guys, so I don't want to go too much if it's beyond you at the moment, but who thinks they would know how to find the equation of that line? Anyone or no? Right, the equation. What about, let's just do the first thing, which is what is the gradient of that? So your gradient would be the rise over run. So the rise is which coordinate to which coordinate?
Oh wait. 1, -1 to 4. 4 to 8.
Well, rise are the y values, so 4 to 8. Okay, 4 to 8. And the x values are the runs, so
-1.
2, 5. So 4 to 8 would be a rise of 4. And the run would be 6. Okay? Which would be 2 over 3. Right, what if I were to write that as a decimal? What would you write it as? So it's 0.6 recurring, and that is just not an accurate number to use. So the next stage, which would be finding the equation, would be nice, well, not easy, but easier with it in this format. Really impossible with it as a decimal. So try and leave it as a fraction. So what we'll do, you're obviously all at different stages within the booklet, so I'll let you carry on working at whatever point you are. Right? Remember though, what we want to be able to do is these things. So if you all about the gradient, maybe the next thing is being able to find the equation of the line as a whole. Okay, let's have a look at a few. Let's get moving, because I think, you know, it's quite quick when we get going. So let's just make sure that we make best use of time. So back to this one. Let's go through. For each one, we want rise over run. So basically, with all of these, like this line, for instance, can I just make the point? That looks like it's on the point, but it's not quite there. It's slightly off. So you've got to identify a point where it is definitely on the line. And for this line, the only one that's clear, so we've got this point and this point. Okay. Now, to show you something that you might not have realised, this one, we've got rise over run is 10 over 2. You're happy with that, yeah? But what if I did pick this point here? What would it be? It would be a run of 1 and a rise of... No? What would that rise be? 5. So, if I did the whole thing, it would be 10 over 2. But if I only did part of it, because I know a point halfway, it would be 5 over 1. Is that a different answer, or is it the same thing? It's the same thing. So actually, as long as we find 2 points that definitely lie on the line, we're all right. So same with this one. It was -4, 10. But if I find this point here, for instance, it's a rise of -2 and a run of 5. So it would be -2 over 5, which is what we simplified to anyway.
This is like when you do this triangle.
Yeah, it's the triangles. Okay, so we can do it. So this one, there is no intermediary point. We just use the 2 ends. So we know it's a run. Okay, a run of -5 to 5 is 10. I'm putting my rise
This is 9.
is -5 to 4, which is 9. So it's 9 over 10. Can I simplify 9 over 10? No, just leave it as 9 over 10. Okay. This one, obviously, as we start getting more confident, we don't need to write it all out. I know, what do I know? If it's going this way, it must be a negative answer. So I'm going to put a negative. So many people forget the negative. So I go from 5 down to -5. So I know it's -10. That's the drop. And then the run goes from -4 through to 3 makes 7. So it's -10 over 7. Does that simplify? Nope. This one, again, the run, a lot of these are easy. The run is 10. The rise is a negative, and it goes from 3 down to -2, so it's -5. Does that simplify?
Half.
Negative a half. Good. Okay.
Wait, the negative goes to the whole fraction? Or just in one?
It doesn't actually matter. Do you remember your work on multiplication and division of negative numbers? So -1 divided by 2, or 1 divided by -2, or -1 divided by 2. Does it make any difference? It's always a minus answer. So it doesn't actually matter where you put them, negative.
Cuckoo.
This one, our rise is from 5 down to -5, so it's -10, and we go run of -5 all the way through to 5, so it's 10, so -10 over 10 is -1. Okay?
Morning, sorry to disturb you.
It's okay. Okay. So just to show you the answers here, look, and the final two, -5 over 4 and 10 over 7.
Where's that?
I got -10 over 8.
Oh, I got 10 over 7.
Yeah, 10 over 8, 5
I
over
got 8
4.
over 8.
Yeah. -10 over 8.
Where did I get 8 from?
You got a negative. Well, that one can't be a negative because the line goes up.
Confused.
Wouldn't this be a 9 if it goes from 4 to 5?
Okay, it doesn't though.
It goes from 4 to 3.
It goes 3, -4 to 3.
Oh no, I got that. Okay, now I'm more.
Okay, the next one. Any questions, or can I just give you the answers?
Answers. Answers. Oh boy. What?
Now, so for ones like this, if it gives you a whole answer, give the whole answer. Okay. Simplify. So -10 over 2, for instance, should be negative 5. You will be penalised if you leave it as negative 10 over 2,
Oh man.
because that's a fraction that can be simplified to a whole number. Okay? So move down. Now actually, if you're able to work with the fractions of gradient, that should be pretty okay, because most of them will be whole numbers here. Number 4. Number 4, did you say? 6, sorry. Okay, this one. So remember that rise is the y coordinate, so it's the change in y, and the run is the change in x, so y and x. So what I do, the change in the y coordinates is 5 to minus 2, okay, is minus 7, okay, and the x is from minus 4 to minus 5 is minus 1. So I've got a minus and a minus, which equals a positive, so we end up with 7. Okay. Any more questions on any of those? Okay.
Wait, the last one.
I just proved my 2. Is that what you just said? No. I pursed.
The next page. Okay. Is it this one? Okay. Right, what I want to do, because not everyone is ready for the answers here, what I want to do is go through it, because this is where we really start getting to the point where it's what you need to understand. So, what I've got here, this sheet, was about introducing you to the form of the equation y equals mx plus c again. Okay, so y equals mx plus c. That is the general form of a linear equation. Okay? We've got 1 minute. So what that means is the information that we're getting about gradients and about where it crosses the y-axis comes from the equation. So I've put here, for instance, if I've got y equals minus 5x, okay, the minus 5 is the m, and that is the gradient, the slope of the line. So it's as simple as, well, what's the gradient of this one? Minus 7 over 5. Okay? And I will explain this. Remember the ordered pairs? So if I know the y-intercept, that means that on the y-axis it crosses at that point. Okay? But actually it should be that way around because it's minus 5. Okay, it crosses at negative 3. Alright? Now what that means is when I put 0 in, alright, when I put 0 into the function, I get minus 3 out. Okay? Now the minus 3, you'll notice, is there. So, because I put 0 in, so minus 5 times 0 is 0, minus 3 gives me the y answer. So for this one, the y-intercept will just be 0 minus 3 again. So we can use this form of the equation to find our answer. Okay, carry on with this next time.
Okay.